I am Chili, and this is lesson 15 of the beginner series. Let's get it on. We're talking about structures in this lesson, and hopefully it will not take that long. I really don't want another 2-hour lesson, so I'm going to try to make this quick. But before we get to the topic at hand, I just have a few announcements. I've been pretty active, pretty busy lately. If you've kept up with the feed, I've been posting links and giving you guys updates on what I'm doing on the feed here, and I've been linking to the blog so you guys can. I don't know if you guys are aware of this, but there's a blog in the main Planet Chili page, and and for the first few months I didn't update it at all, but lately I've been keeping up with it, so check this place out every now and then, and you can get some info on the progress of making the tutorials. And yeah, there's the board as usual. It's been a lot more active than it has been in the past few months, so we're seeing a few more games and shit. Now, the thing I wanted to tell you guys about is in the past few days I've been updating the framework. Yeah, so a lot of you guys have been asking for stuff like mouse support and audio support, and so I threw it in there. I'm not going to cover this stuff in the tutorials for a while. Mouse support will come not too far in the future, but audio will definitely be it's not a main priority of mine, so don't expect me to go over this shit in detail. But if you want to play around with the audio, if you want to add some sound effects when you're making games, practicing your programming skills, then you go right ahead and do that. I've made it pretty damn simple, so all you gotta do is check out the here I have some of the example projects that I made just to demonstrate how this shit works. So let's see if I can get it up here. This one is our old familiar Pooh Face game, but the input is with the mouse, and there's audio. I don't know if you guys can hear that though, because I've got this hooked up to my my microphone, so you probably can't hear. 1 second. No, I can't do it. Damn it. I was just thinking I could switch the input, but I'd have to stop the video to do that. Well, wait a second. Nah, I can't switch my audio input when I'm recording, so you'll have to take my word for it. It's got sound now, and it's got mouse support. The other one, what was this? Here's the other. Oh, here we go. Yeah, here's the other example I made. Just a very simple sketching program using the mouse, obviously. So yeah, you guys can. If you're thinking about making a little game, you can check that out. The updated framework. It's on the forum. Another thing I wanted to show you guys is one of our board members, Lux. He has created an image scanner here, and how this works is you get I'll just get this file here. You get a bitmap or whatever, and you drag it on to here. You load your image, then you got to type in the image width and height in here. So that would be 20, and then you've got to type the transparent color. So this one is, I think that color is called cyan. Cyan is red and blue. No, that's not cyan. It's purple or something. I don't know what that is. It's ugly. That's what it is. So you type this information in, and then you click scan. And what this thing will do is it'll scan through the image, and it will generate a list of put pixel calls for the image. And then you can use this list of calls in your game. So you can even go and click Save Text. I'll save that and close the program. And if I go here, the generated text file, there's all the put pixel calls. And then you can copy and paste this shit into your own game. And you can get, you know, sprites other than the face and the poo and shit, without having to hand code all of the put pixel calls. So that's very cool. Very big thanks to Lux for that, and you can get that on the forum, and the link is also on my webpage. What else? Oh yeah, so a couple of guys have created some programs here. I just want to show you. Here is like a weird kind of sword fighting game. It's pretty cool. I don't know, the health bars on top of the enemies make me think, always when I look at this, I always think of like a real-time strategy game. But so you what is it? I think it's Spacebar. There it is, Spacebar. There we go. So you run around and, I don't know, kill a bunch of the box guys. Yeah, you do that. There we go. So it's a very neat little program here. The scrolling is very well done, and I like how the background is kind of animated there. You can see it like flashing and stuff. Very cool. So that one was done by a guy on the board named K-Pence. Kind of like K-Fed, only not like him at all. What else? A fairly new member on the board who just joined, I think, a couple days ago. His name is Fly High, and he made a Arkanoid clone. Yeah, he made an Arkanoid clone. So that's cool. That works fine. The mechanics of the ball are pretty good. I don't know. I like the game a lot. It also has, you can also restart the game if you press enter, which is something that I should have put in my game, because, whoa, that was sweet. Anyways, so yeah, this is Fly High's contribution, and very similar to that, this is another one by XX. What happened here? Check this out. Oh, okay, here we go. So you probably can't hear this, but this one's got sounds, so it's Pong, and that's pretty fun. Ah, shit, I lost there. That was horrible. There we go. So yeah, XX has made a another contribution here. Yeah, take that. Ah, shit, I thought I was gonna get that one. Come on, yes. So yeah, the fellows on the board have been busy making games and shit. And yeah, last thing I wanted to announce is I created a demo program to basically show off how you can scroll in the game, how to implement scrolling in a game. That's what I meant to say. And so yeah, this is just I put this code on the web page, and you can check it out. The one on the web page, it doesn't have mouse input, by the way, so it's just keyboard, but it's the same idea. And so if you're wondering how you can do scrolling, check that out, and I hope that will make things a little easy for you. I added a lot of comments to this one because, you know, I'm not actually explaining it. We will do scrolling eventually, of course. Just in the natural course of the tutorials, it will come up and I will explain it. But until then, you can take a look at my source code here and get an idea of how that can work. All right. Okay, so it took a little longer than I wanted it to, but had a lot of cool stuff to show off. Now, back to the matter at hand, which is structures. All right. So what are structures? Structures are a type of data. So we've done simple types of data like int, float, and bool, right? And these types are what are known as intrinsic types. So they're the types that are built right into the C language. They're the simplest of the simple. And we also did a type which is enumeration or enum, and this is a user defined type, right? And if you remember enumerations, they let us define a data type that can only take on a certain set of values. Now structures are also user defined type. We have enums and we have structs or structures, but structures are a little different. They are an aggregate data type, and that's just a big fancy word that means you can stick a whole bunch of data types, lump them together into one structure. So how to explain this? Up until now, like take for example our poo game. In our poo game, for our poo objects, we have 4 arrays, right? The arrays are poo x, poo y, poo velocity x, and poo velocity y. And each of these arrays has a number of elements, right? So for example, the first poo object is represented by the first index, or the first entry, the first element of each of these arrays. Yeah, element, that's the word I was looking for. That's the ticket. So yeah, you take the first element here of each of these arrays and you get your first poo object, which by the way is index 0. Don't forget that. And yeah, that's fine, but it's just a bunch of loose arrays. I mean, the first thing we had was we had like poo x1, poo y1, and poo x2, and poo vx1. And we had like all these loose variables just kind of floating around. All their junk. It's like your junk is all hanging out and it's flapping in the wind. It's no good. That's not good at all. So then we kind of we lined them all up into little boxes here, and this was better, but it's not the best because they're still kind of loosely grouped together. Now what structures let us do is they let us define a structure data type. So we'll call this structure poo, and inside poo we have a number of members. I forget if that's the right term for structures, but I'm going to say it is. Members. So this structure has members, right? So it'll have members and they'll be floats. So this structure contains multiple variables inside of it. So we'll have a float, we'll have this one will be x, this one will be y, this one will be vx, and this one will be vy. So that's the name of our members of this structure, the poo structure. So we define a structure type poo, and the structure type poo has 4 members, x, y, vx, and vy, and they're all floating point values. And then we can create individual poo objects. We can say poo1, we create a new poo object or structure. And then we can say, okay, poo1 dot x or poo1 dot y. And yeah, poo1.x is equal to 0.1f or something like that. I don't know. You get the idea, right? The idea is that all the variables relating to poo1 are all stored, they're all kept together, they're all lumped together. It's much better organization than having them all floating out in separate unrelated arrays. And it's much, much better than having them all just single variables floating out, flapping out in the wind. So, the first, I don't know, reason to use structures is organization, right? Organization. Organization is key. And we can create, once we define our new poo data type, we can create individual poos, poo1 or poo2. What we're going to do is we're going to do poo, and we're going to say poo, and then we're going to be like npoo, right? So we're going to create an array of poos. All right. So, I mean, before, last thing I'm going to explain here. Before we had our memory, right? And we had our 4 arrays. We had our poo x and poo y and poo vx and poo vy. So we had our 4 separate arrays in memory here. And if we wanted to access, you know, poo0, we would access the index 0 of each of these arrays, right? But now what we're going to have is we're going to have an array. So here we had an array of floats. So I'm going to just make that clear. Float, poo vx, float, and float. But now we have an array, just one array of poo objects. And each of those poo objects has 4 members, 4 floating point members. Float, 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 which are x, y, vx, and vy. And again, we haven't, this will be poo0, and this will be poo1. Again, x, y, vx, and vy. Damn, this is getting incredibly illegible. Anyways, you get the idea. So if you want to access poo0, you're just accessing this structure here. So it's a little different organization, and it's better. There are other reasons to use structures. There are things that you can do with structures that you couldn't do without them. But for us, I think the main reason to use structures will just be organization. I will show you one other thing you can do with structures, though. Just hold on. Alright, so let me just close this off, get me some space here. So to define our structure, I'm going to go up here. You don't have to type private. We won't type it. So we go struct poo, open bracket, and then we define the members. So float x, float y, float vx, float vy. And don't forget this semicolon here, because it's easy to forget. But when you're defining a type, you have to put a semicolon after the closing bracket. don't put a semicolon after the bracket in a function, right? But when you're defining a type, like a structure, and if you notice here at the end of the class definition here, we also have a semicolon. And same with enumerations too. When you define a user-defined type, at the end of the closing brace, you have to put a semicolon. All right. So we've defined our new structure type. It is called poo. And now we want an array of poos. So we go poo, poo, and poo. Poo poo, poopity poopity poo. And now we have an array of 25 poos. So now we have our work cut out for us because we have to change our code again. So let's take a look here. Poo x at index, poo x velocity, poo y velocity. Now I'm pretty sure I can pretty sure that there is an easy way to do this. What we're going to do is we're going to do a find and replace. And let me just make sure this is on the screen. Okay, here it is. Why is this so freaking wide? Quick replace. We're going to replace poo y velocity at index with poo at index dot vy. Replace all. 7 occurrences replaced. Now we're going to replace poo x velocity with poo index at vx. Aren't I just a clever little bastard? Alright, next is poo x at index. Replace that with poo at index dot x. Replace 9 occurrences. And poo y. Poo at index dot y. Alright. So that is that all sorted out. Poo at index dot x. Alright. Just makes me feel that much better knowing that they're all structurized now. I can sleep easy at night. See if I get any errors. No errors. So, these I thought I could control them with the mouse. All right. So yeah, as you can see, exact same result. The only thing that changed is the way the code is written, and the way that the data is actually represented in memory has changed. The whole organization of our data has changed, but the user is none the wiser. So I mean, from now on, we are going to be using structures to represent things in our games. For example, let's say you have an RPG. So you're going to have a character, and that character is going to have hit points, and he's going to have an XY position on the map, and he's going to have, I don't know, like an inventory and a name and shit, and you put all that stuff into a single structure, and you call that structure player or something like that. Just an example. Instead of having loose variables hanging out, chilling out all over the place, you group them all together, you lump them up, and makes it easier to understand the code and to maintain the code that way. So I mean, if someone's just looking at your code and they want to see what variables are all to do with poo, all they got to do is go dot, they got to type this dot, and they can see right here, okay, so poo has a vx, a vy, an x and a y. It's very simple. You don't have to go hunting through lines of code trying to figure out which variables belong to which objects in the game or whatever. Makes it very nice and explicit and organized and good. And we like that. We like organization. We're programmers. If you don't like organization, then get the fuck out of here, because Jesus, you're not gonna be a good programmer, honestly. I mean, I'm a pretty messy person, but when it comes to coding, you gotta have a certain degree of OCD. Otherwise, your programs, they just collapse under their own weight after a while. Anyways, yeah, enough of my diatribe. That is structures. It's that easy. And that's why this lesson, I've only been talking about this for 15 minutes now. So I'm going to show you one thing you can do with structures that you couldn't do before you had structures. Let's see here. Alright, so we're going to make a function. And we're going to call that, what the function is going to do is we're going to give the function 2 points. We'll call the points P1 and P2. And what the function will do is it will return the midpoint between these 2 points. So it'll return a point P3, which is exactly between P1 and P2. So it's on the line connecting P1 and P2, and it's equidistant from both P1 and P2. If you want to get all technical in the definition, we'll call the function midpoint. So it'll take int P1, int P2, and it will return. What will it return? Now here's the thing, and maybe you've already figured it out. Functions can only return one value. So they can only return, for example, one int or one float or one bool. But a point is an ordered pair. So it has a, well, this one would have P3x and P, that's a beta, P3y. That does not look like a P at all. That's somewhat better. Yeah. Right, that's 2 values. That's 2 ints. How do we return 2 ints from a single function call? Well, what we do is we define a data type. Well, this is all fucked up too, right? Because int P1, you can't have that. You'd have to have int P1x, int P1y. Fuck. I was getting ahead of myself, you see. Int P1x, int P1y, int P2x, int P2y. Yeah, that's what you'd have to have. And you'd have to return, and you'd be fucked, because you can't return 2 things at once. That's just not the way C works. So what do you do? Well, what you do is you say, okay, I'm going to define a structure. We're going to call that structure point. Point has int x and int y. I'll put this thing here. And there we go. We've got a new data type, structure point. And then I'm going to say, okay, so midpoint returns a point. And while we're at it, why don't we stop fucking around with all these variables here? We'll just make things simple. It takes 2 points. It takes a point P1 and a point P2. See, that's where I was already skipping ahead in my mind when I wrote that thing before. So if we do this, well, yeah, then we can return 2 ints because they're all lumped together in one point structure variable type. So by using structures, you can return a whole shit ton of stuff from a single function call if you wanted to. So let's do that, just for shits and giggles. because, you know, this video's, I haven't actually been doing that much coding in this video. Feels strange not to be, you know, rattling on for 2 hours. So we're going to create a function here, and I'm going to do it a little different. I'm going to show you something else new here. I'm going to create it as a global function. So I'm going to define a point. I'm going to define point up here. We got structure. Struct point int x int y. That's done. Now notice that this struct point is not inside of any function. I did not declare it, for example, inside of game like I declared poo. So point is not a member of game. It is this is called globally declaring it. So it's just chilling out there in space, really. And I'm going to create a function down here. It's going to return a type point. We'll call this function, we'll call it midpoint. And it takes point P1, point P2. Good. All right. So how do we find the midpoint between 2 points? I think it's pretty simple. So we create a point variable, call it P3. P3 dot x is equal to P1 dot x plus P2 dot x divided by 2. So I believe it's just the average of the 2 points. If my grade 10 math hasn't failed me. We got P1 dot y plus P2 dot y divided by 2. And then we just do return P3. All right. And yeah, we've defined the midpoint function here. And it works fine. So now we have a midpoint function. What I'm going to do is I am going to draw a disk, a blue disk, at the midpoint between the face and the disk, the goal disk. I don't know why I'm doing this. I'm just doing it. I just feel like it. Feel like it's something that I need to do. So we're going to do gfx dot draw disk. All right. First, I'm going to have to do point midpoint. We'll just call it mid is equal to midpoint. What is it? Ah, you bugger. Yeah, so if I use structures for this stuff, then I've got to make the structures. That's the problem with this thing. See, the whole this whole program is not using point structures. So what I've got to do is I've got to do point P1, point P2. And then we go P1 is equal to, no, P1 dot x is equal to, we'll say that this is face x. P2 dot x is equal to face y. P1. Let's not do that. That way I won't have to pull my hair out later trying to wonder why the fuck my program isn't working properly. Let's do it properly. Goal x p2.y is equal to goal y. See, this is kind of a pain in the ass. Now I'm wishing that I would have just defined this in like int p1x, int p1y, blah blah blah. But I mean, if this whole program was using point structures, like instead of goal x, goal y here, if this was just goal, right, or goal dot, I don't know, position, goal dot position as a point thing, and like all this stuff here was, instead of face x, face y, it was just face dot position or something like that. If we were just using point structures everywhere, then I wouldn't have to do all this shit. I could just plug the our variables in directly. But because we're not using point structures, I have to first load up p1 and p2 with our variables, and then I can pass it p1, p2. Then I can pass these 2 points to a midpoint, and the midpoint function will find the midpoint for me, and then I can draw the disk at mid.x, fuck you, mid.y, and radius will be 5. The color will be RGB 00. Actually, we'll do it 100, 100, 255. A nice light blue color. Alright, so this will draw us a disk at the midpoint between our face and our goal. Let's try it out. Failure! Midpoint identifier not found. Now why is that? It's right here. Why can't you see it? Now the problem here, which is another short thing I just wanted to show you guys, a teaching point if you will. The compiler only knows about things it's seen up until now. What I mean to say is the compiler runs from top to bottom, and whatever it comes across, it remembers. So first it's going to look at game, so it'll know everything that's defined in game. It'll know about game objects. It'll also know about D3D graphics, because D3D graphics is included in game.h, and it'll know about keyboard. Then it'll also know about stdlib, time, and math functions. It'll know about points, because point is declared up here. And then we go down to here. So it knows all about points and shit, but it has not seen midpoint up until here, because midpoint has not been declared. Here it's defined down here, but it's not declared. So there's a bunch of ways we could solve this problem. One way to solve it is just to do what's called a forward declaration. We go point, midpoint, point P1, point P2, and then we end it with a semicolon. And what this is saying is we put this function prototype up here, and we're telling the compiler, hey dude, there's this function. You haven't seen it yet, but trust me, it's there. So yeah, just remember that this thing is a function. And then when it gets down to here, it's like, oh yeah, this is that function they were talking about up there. And so it just kind of, it says, okay, I'll believe you. And then when it gets down here, it says, okay, so this is how that function actually works. And then it links this function to this function call. But if you don't do forward declaration, it has no idea that midpoint is a function. And it's like, what are you talking about? That's not a function. You're crazy. And it gives you an error. So that's one way to solve the problem. You do forward declaration. And guess what? You see these include files? That is all they are. Let's go look at math.h. Open document. See? Well, it's actually got a bunch of shit. It's got define things here. These are all constants that are defined. But here, these are a bunch of function prototypes. See? It's a function call. This is a return value. This is a special thing that you don't have to worry about. Here's the function name, for example, sine, cos, and here's the type that it takes, double. But you see this semicolon at the end, that means it's a function prototype. So all those H files, all they are doing is they're doing this shit. They're just basically telling the compiler, hey, here's a bunch of functions. These are real functions, dude, so trust us. These functions are out there. So yeah, you can put a function prototype at the beginning of the source code, and that will allow the code to know, the compiler to know about the function. Another thing you can do, it's not always possible, you can just define the whole function at the top. And if you do this, then it's fine. See? Succeeded. No problem. Because, I mean, then it knows about it. And it even knows the implementation too. So that's another solution. Just put it at the top. But sometimes, because of the way the functions call each other, you can't avoid having one before the other, and it doesn't work, so you have to use forward declaration. But yeah, this is a global function, so you don't have to do anything like graphics dot, midpoint or something. You just type midpoint. It's just like square root or whatever. You just type it. Square root is also a global function. It's not part of any object or anything. So let's see if that worked. And it did work. Watch. Whee! So yeah, it's at the midpoint between our face and our thing. Our dotty thing. Actually, it's kind of fucked up because I'm not using the center of the face. So I'm just gonna... It should be face plus 10, right? Because the face is 20 by 20, so... So now we have it at the midpoint between our face and our thing here. And I don't know, it's kind of cool. It's pointless, but it helped me to demonstrate something. Which is that you can create functions that return structures, and thereby you can return a whole shit ton of data in one fell swoop, if you wanted to. If that's the kind of thing that you want to do. And the other thing, I just want to show you global functions. One last thing I want to show you is let's see here. Let's say I wanted to use the midpoint function. For some reason, I wanted to use it in my graphics.cpp file here. All right. So I'm just gonna find draw disk, and for some reason, I don't even know why, I'm gonna go point p is equal to mid. Fuck. I gotta create a bunch of points. I wonder. Oh, fuck it. Point P1, point P2. X is equal to 100. P1.y is equal to 100. P2.x is equal to 50. P2.y is equal to 20. Alright, point P3 is equal to midpoint P1, P2. Now you already noticed that IntelliSense did not pop up for any of this crap. So already there we know that there's something wrong. And it's like, okay, the compiler, I don't know what the fuck point is, and what is all this P1, P2 shit you're talking about, and midpoint, what the hell is that? What are you going on about, crazy programmer dude? I don't know what you're talking about. Cool story, bro. So why is the compiler not, hip to our jive talking? The problem is that, this is a separate, the whole separate thing than, what is it, game.cpp. I forget what the term is. I think it's like compilation unit or something like that. Whatever. So anyways, these CPP files are completely separate from each other. They compile to separate modules that are linked together finally. So, just because we've declared something at the beginning of game.cpp, d3dgraphics.cpp doesn't know anything about that shit. It's like, I don't know what you're talking about, bro. So what you got to do then is, well, you could go could do something like this. Copy this from here. You could go to graphics.cpp. You could paste this declaration of point, and you could also put a prototype for midpoint in here. Then try to build it. And it worked no problem. So you can copy and paste shit. Now, one thing I want to make you aware of is you could not copy the whole midpoint function from here and paste it into here. Build. Now you get a link error, and the link error says already defined in d3dgraphics.object. So you cannot have two separate definitions of the exact same function. There can be only one, right? So that means, for example, if we say game.cpp is the main one, then game.cpp will actually define, that's where the function will actually be. And in every other file where we want to use midpoint, we just give its prototype. And we could do this. We could copy and paste this this code into any kind of file where we wanted to use the midpoint. But that's not how we do it. So how do you think we do it? Have you figured it out yet? We put all these kind of declarations inside of a single header file, right? We declare our data types and our functions inside the header file. In this case, we'll declare it in game.h. And it's already declared, so we can get rid of this. Delete that. And then in every file where we want to use those functions and those data types, we go #include game.h. And there we go. Success. And now we don't have to copy and paste all that shit into every file we want to use. All we do is we include game.h, and it gives us all of the definitions here. And that is why we have header files. That's what they do. We just include them in the source files wherever those functions or those data types are needed. Now, of course, we don't actually need it in here, so I'm going to get rid of it. Yeah, get rid of this too. So yeah. So the moral of this story is that we don't need to declare our functions and our data types in header files. We don't need to do that. We don't need to give these prototypes in here. We can do it all inside of the CPP file. But if we want to use that function in other source files, then it makes way more sense just to put it in a header file and then include that header file in here. Because if you got to copy and paste all that shit into every one of these files, and let's say you change the arguments for the function. Let's say you add a third argument into here. Now, if you were copy and pasting, you'd have to change it here and here and here and here. But if you're using header files, you change it at one point and it changes in all the other ones because it's just including this file. So, I just wanted to let you guys know about the glory of header files while I showed you some other shit. And now the shit has been shown. So yeah, and now because we have this declaration here, we're free to include the midpoint, we're free to define the midpoint function anywhere we want. So we're going to define it down here at the bottom. Just because I like the bottom. You got a problem with that? Are you racist or something? You're racist, aren't you? Alright. So yeah, that's midpoint for you. Useless, but there you have it. I'm gonna get you with my blue dot. Whoa, you thought you could get away from me. Come on. I know you want the blue dot. Come and get some blue. Gotcha. I got you. Alright. So yeah, that's structures, and they're good, and we're gonna use them a lot later on. Last thing I want to say is these global functions. We don't use them that often because generally we want to keep our data and our code tied together inside of objects. But sometimes there are some functions that are just general usage tools, like for example math functions like sine and cos, and they don't have any real data associated with them. So it doesn't make sense to make them into structures or not structures, but it doesn't make sense to make them part of some kind of object. So for sine and cos and all those utility functions, it's just better practice to make them global functions. But in general, for your game functions are going to want to access your game variables. So you're going to want to make them as member functions of the game object. So don't go crazy and make a whole bunch of global functions just because you can. But just wanted to let you know that this is how you do that sort of thing. And I mean, before C++, there was only global functions. There wasn't any member functions, right? So if you ever have to program in straight C, you have to know about these things, how they work. And that is how they work. So, my mouth is starting to get dry, and my throat's getting a little sore. So I think this would be a good place to end the tutorial. So I hope you've gotten a decent understanding of structures, and you've gotten a little bit of an understanding of global functions, forward declaration, and why we have header files. Alright, and that is the end of the tutorial. Tutorial over.